Okay, so really, remember yesterday we kind of talked about science was initially used as ways of keeping poor people poor. And people who had money, they would go to school and they would get their education, right? And so this is one of those things that you guys will learn. We have certain words that, man, they look exactly the same, but they have very specific meanings. So solution is a combination of the solute and the solvent, right? The solute is typically the smaller component, the one that we have the least of, okay? That's going to be our solute. Smaller quantity. Okay. The solvent is the one that we typically have the most of. Okay, so we like talking about soda. Soda. What do we have the most composition of in soda? So we have sugar. Well, if it was sugar, it would be all sugar at the bottom, right? So we know it's not sugar because it wouldn't be able to be dissolved, right? So it's not sugar. Somebody said carbonation. Well, we have carbonation, but it's not the most abundant, right? It's actually the water. Water is the most abundant material in here, right? And if you take a look at it, they actually did one, they said carbonated water, right? So they kind of tricky on the way that they did it because they said, well, carbonated water, that is the most abundant. When you look at ingredients on product, the one that's listed first is the most abundant. Okay, just for there. Okay, so a solution is just a solute and a solvent. Solvent, one that's going to be the most abundant. Solute, the one that's going to be the least. Okay. The other way of looking at it is the one that's going to be dissolved in the other. So water dissolves sugar, right? So water is going to be the solvent, and then sugar is going to be the solute. Okay, questions?
What you said again?
I said the one that's going to be dissolving the other, right? Okay, and what you guys think about this? Just one moment, think about it. So I'm gonna have a cocktail, had a long day at work, been grading all your labs. I get home, rough day, first day of class, nobody wants to talk, everybody's trying to be shy, right? So I'm like, gotta have a cocktail. So I'm gonna have a little scotch and water, right? Now, I know I can handle my liquor, right? Not the way I used to, can't turn it up the way I did when I was in my 20s, right? So I'm gonna have a little scotch and a whole bunch of water. Right? So I want to nurse it a little bit, okay? So what is the solvent? The solvent? The water. So why is the water the solvent? It's the one that's going to be the most abundant. Then the solute must be. Did you say the apple?
I said alcohol.
The alcohol, yes, no, the alcohol, exactly. Yes, the alcohol is going to be the solute. So when they give you the drinks at the clubs, right?
Okay.
So which one are the solute?
You went the juice.
The juice.
Whatever they mix it with.
The alcohol,
Or the alcohol,
right?
sorry.
Yeah, because they water your drinks down like crazy, right?
Sure do.
You're paying top dollar for a really little bit of alcohol, right? Yeah. Okay, so you guys want to think about it in those terms, right? And then again, you're going to see this again and again and again, and it's going to be phrased in slightly different ways. And so the key is to be able to decode what is being said. Okay, that is one of the biggest things that communities like ours, we have trouble with. We have to learn how to decode. There's that little code. So that means we got to keep track of those terms, right? Okay. So you said the definition of homogeneous was, say it again?
That's a solute that is uniform.
Okay, he said a solute or a solute. It can't be a single solute. Solute that is uniform in appearance and composition. So if I have sugar and salt, and I put those together, right? Is that a homogeneous solution?
Yeah, right.
Because it looks all the same. Can you guys tell the difference between sugar and salt? I can't. I mean, if I taste it, I can, you know. But if you look at it, I can't. Right? Well, it depends, because everybody says, "Oh, this on the grains of salt. Salts are bigger." Well, I got some fine salt that'll look just like sugar, right? Because they grind it a little bit finer, right? So, but yeah, they started doing that recently because they got tired of kids putting salt and sugar into the little shakers at Denny's and stuff. I did that when I was in middle school or something like that. Okay, so what about rum and coke? Rum and coke. Is that gonna be homogeneous or heterogeneous? What is the opposite of homogeneous? Heterogeneous. Okay, homogeneous, heterogeneous, right? Homo meaning same, hetero meaning different. Right? Okay, so what was our last question? What are exam corrections? Okay, how much do you get back? Half. So you got a one-time opportunity, right? Opportunity to sit there and do a correction on the exam that you did poorly. Right? So, okay, so that was your first quiz. You're gonna occasionally get quizzes. It depends on how I'm feeling, because I like it to be interactive, and I want to make sure that you guys are actually listening to what I'm saying and not just talking just to talk. I do like to talk just to talk. Don't get me wrong, but you know, there's usually a goal behind it. Okay. So let's get started with the lesson. Are you guys excited about today?
Yeah.
So let's start off simple first. Let's start very general. What is science? What's it?
Study of something.
Study of something.
We just asked Google.
You can ask Google. No, I don't want you to ask Google. I want you guys to tell me what science is.
The study of non-living and living things.
Study
Right.
of non-living and living things. Okay, that's good. Okay, so in science, we typically start with questions, right? How many of you guys have kids? 2, 3, 4. 4 of you guys have kids? How many of you guys have nieces and nephews? How many of you guys have brothers and sisters that are little? Okay, okay, good. So at least somebody has somebody small in their family. Now, I'm gonna ask you something. Do your kids, your nieces and nephews, your brothers and sisters, come up to you and say, why is the sky blue? Why is the grass green? Why is that grass yellow? And that grass green? Right? Do they?
Yeah.
Yeah? They do, right? And what do you guys say? I don't know. Get away from me. I'm playing the PlayStation. Leave me alone, right? That's what you say, right? Right. So those, your siblings or kids or cousins, right? Those are young scientists, because that's what scientists do. That's what scientists should be doing. Okay, you okay? You tired?
Yeah.
We're gonna set you up with the chair. We'll try to get closer to the side there. So those are young budding scientists, right? Because good scientists should be asking questions, right? They should be asking why, right? And you guys, who are also budding scientists, right? Should be asking why. Why? Why, Dr. Amy? Why is that the case? Why? You've got to want to know, right? Because you want to be the best in what you do, right? So you've got to ask me why. Why? Okay? So if I go through a lecture and somebody don't ask me why, I'm going to be a little upset at the end of the day. I'm going to go home and cry my tears and drink a little bit of scotch. Okay? So you guys don't want me to be an alcoholic, so you got to work with me, right? Okay, good. Okay, so scientists will always ask why. Okay? So we always start with why. Why something else? Why something? Why is this that? Okay? So we want to start off with why. The next part is that we start thinking, right? Your kids will probably start thinking, well, the grass is green because the dog peed on it, right? Is that why the grass is green? Or is that why the grass is yellow? Right?
Yeah.
Okay, so they're gonna start thinking about why things are the case, especially when you don't tell them the answer, you say, I don't know. Well, they're gonna start trying to figure it out. Now, that process is developing what? What was that? It's developing a hypothesis. So a good scientist should be able to develop a hypothesis from the questions that they're asking, right? Okay, and then what does a good scientist do? What was that? They test it, that's right. So the third thing would be to test it, right? So we have ask questions, develop a hypothesis, we test it. Okay, now if all of the answers are perfect, then what? What's that? They have a nice little theory, right? And they publish it and make fame, right? In theory, right? Okay. If it isn't perfect, then what do?
Do it again.
You do it again. Because you want to be sure first off that you didn't make a mistake, right? And then what else? And then if you do it again and you got the same results, you change what? You change the question or do you change the hypothesis? You change the hypothesis. Okay. So you reevaluate your hypothesis, you make changes that are necessary, and then you set up your next set of tests. Right? Okay? You see how that works? So that's called scientific method. Science is based upon scientific method. Okay, everybody got that down? There will be one question that will random, that'll pop up somewhere on scientific method. But you guys already knew that, right? I'm not telling you anything that you haven't heard since you're like knee high, right? Learned that in middle school. Right? How many of you guys practice it? Every day? Yeah. How many of you guys are old enough to drink? Okay. How many of you guys are not old enough to drink? Okay. How many of you guys have drank? Let's see. That was, I'm like, yeah, right. Okay, so I'm not going to call you liars or anything like that, but let's assume that you're not telling me all the truth here, right? So how many of you guys drank when you guys were underage? Who are exactly? See, they're honest about it. It's okay. It's okay. This is a science class. We're going to talk about some uncomfortable stuff like this, right? And you're gonna get used to it a little bit. And I'm very uncomfortable. You'll be a little uncomfortable with me for a while, and then you'll open up. It'll get easy. Okay. So now, as we kind of test those hypotheses, right? What did you guys do the first time you went out and drank? Did you guys turn up? Did it turn up? You're just like, were you sipping?
I was passed out.
I see, exactly, right? So she was really testing out that hypothesis, right? She was like,
I took
Right?
it to the grave. I
Right?
went all the way.
and so, but you learn the lesson because after you have that first experience, or you always say, or at least you say you learned the lesson. You always say, I'll never do it again. And you're praying to the porcelain God, God, please, please, right? Right? Isn't that the case?
Yeah.
We're always saying, oh, never, never, never again, right? So we've learned those lessons over time, right? And sometimes we have to reevaluate that hypothesis. Got to test it out again. And then we say the same thing again, right? Now you're holding back the hair and everything, and you're, I'm never doing this again. And then as you get an adult, you realize it does not feel good to be praying to the voice of God, right? Okay? So we test out these things throughout life, whether we recognize it or not. And that's what I want you guys to understand, is that we're going to be testing things out. You cook, right? You guys cook?
Yeah.
Anybody not cook? That's good. So I was gonna say, if you don't cook, you're cooking at something, right? So we're gonna be talking a lot about science. We're gonna be talking a lot about hypothesis. And I want you guys to ask me why. I want you to question things, right? You can't just sometimes just say yes, right? Because I say so. Because believe it or not, as much as I think I'm always right, my girlfriend will tell you that I'm always wrong, right? And so the thing is, I can be wrong about things. And it's important that you guys have questions and you guys are curious, right? Because that gets us to that next level. And I want you guys to get to that next level as young budding scientists. Because if we stay here, we're not getting here, okay? And you guys have a lot more to contribute. I expect all you guys to contribute to society, period, right? If you don't, we're coming after you. We're knocking at your door, right? Don't think I won't. Done it before,
You know
right?
where we live?
Oh, yes, I do. I know where all you guys live. If I wanted to find you, I can find you, right?
I got a big address.
Well, that's good. I can still find you, right? Because you got people, right?
Yes.
Mhm. Yeah. So I have my ways. I have my ways. So, but the key is that I expect everybody in this room to be able to contribute at the end in some way, in a positive way. Okay. Okay. So let's get started with this. Today's contribution is by interactive. Let's get this started. Oh, one thing that I have to remind you guys of. So what we're gonna do is we're gonna have this cart here for the drinks, right? And so typically we're not supposed to have drinks or food in the lab. I don't mind if you bring drinks or food to the lab, but they have to be in the cart, okay? And when you go to have it, you know, sort of little area, then you come over here, get a swig of what you need to get a swig of, and then sit back down. I don't mind if you guys get up and go to the bathroom. You don't have to ask me, just, you know, be quiet about it. If you're making a lot of noise to get through, you know, that's something different. But I don't mind. Just go ahead and do it. Don't worry about asking, okay? Especially since it's summer, we want to stay hydrated. Yes, please. You guys can do me a favor and put it there right now. Okay? So, no food and drinks in the lab, right? We don't want to poison ourselves. Everything that I say. So, editing is always hard. And I say a lot of. Okay, thank you guys. So. Camera's not following you today. Okay. So matter. So study of chemistry is basically composed of matter, right? Study of matter, right? Matter is in everything. Like it or not, everything is composed of matter. Okay. So when we think about matter, we have to think about it in three different ways, right? Everything that we do have, first off, has to have mass associated. Right? Even the smallest thing has mass associated with it. We may not be able to measure it, but it has mass associated with it. I am so sorry, I cannot see you guys. This is driving me crazy. I just wanted to get rid of it, but so I'll make a trip to visit you guys over here. So, okay, so the three parts of matter are called macro, micro, and particular. Okay, macro is basically what we're able to see. Macroscopic. Right? We can see with our eyes. We don't need anything special to see it, right? So if you have a dog or something like that, you're able to see that with your eyes. Okay. Now, microscopic basically means that we need a microscope to see it. Okay. And a particulate basically means that we need something that's very, very specialized to be able to see it, like an electron microscope or an atomic microscope, something very focus that allows us to see. It's so tiny that we can't see with our eyes and we can't see with the normal microscope. Okay. So here are some examples. You know, like I said, a dog. In terms of a microscope, if you could see a bacterial cell, a particulate, single atom. You guys can do me a favor. On your desk, I gave you guys their groups. There's these little modeling kits. Okay. Fancy ones out here later on. Because we can't see things with our eyes normally, we have to sit there and do specialized things. If you guys can do me a favor, open up those little boxes. And you guys are like in groups of 3-ish. Let me get another one. You guys open up your box. Good. Okay, take out a couple of those balls. Okay, most of your balls, most of your little kits, they will have either pegs or springs. Do you guys have pegs and springs in your little kit? You have balls, okay? Okay, so these balls are representing single atoms, right? So if you guys can do me a favor, you guys who have the square kit, the big one, right? The yellow balls are supposed to be hydrogen. Okay, yellow balls are supposed to be hydrogen. The ones that have this kit, smaller, longer one, the white balls are hydrogen. If you guys can do me a favor and take out 2 hydrogens. Okay, so there's enough balls for you guys to sit there. Each of you guys can take out. Okay, which would be enough hydrogen. Okay, so a single ball is a single atom. Okay. A single ball is a single atom. Everybody got balls? Okay, so now what I'd like you guys to do is take one of your little sticks or one of your little strings, and I want you to put the 2 hydrogens together, like so. Okay. So this here is called a ball and stick model, right? Ball and stick model of the hydrogen gas, right? Hydrogen is kind of a special case. I'm going to talk to you guys about the special cases. I'm going to write them here on the board. Let me switch my screens here. As I'm saying, I'm learning to use the system here. We're trying to get its fullest potential. So typically when we talk about an element is usually a single atom. Like for instance, if we talk about sodium. Sodium is an example of a single atom. Sodium, symbol for sodium is Na. You guys have your periodic tables available? Now, there are certain elements that aren't stable as a single atom. There are actually seven elements. Okay, so I'm going to tell you about those 7 elements. Okay, so your diatomic elements, the way of remembering them is have no fear of ice cold beer, right? Have no fear of ice cold beer. Have for hydrogen, no nitrogen, fear fluorine, of oxygen, ice, iodine, coal, chlorine, beer, bromine. Okay. Now, these guys form what we call a diatomic element, meaning that in their natural state, they come as pairs. There's 2 atoms. Di meaning 2, atomic, atoms, diatomic element. Okay. Now, the distinction between this and this is that these guys are bonded together. Bonded. You guys know what bonded means? How many of you guys are bonded? Anybody got a boyfriend, girlfriend, significant other? Right? Okay. How many of you guys are married? Right? Married. Okay, so you're considered quote bonded, right? You guys are sharing things, right? In this case, these guys are sharing what we call electrons. We'll talk more about electrons. Okay. Okay, they're sharing the electrons, and so they're bonded together since they're sharing. Okay, where an atom is all by itself, right? That's it. Okay, so this is a diatomic element. This would be, for example, carbon. Black represents carbon. I think you guys all have black. Carbon, right? So carbon is considered to be an element, right? It's not diatomic. It's just a single element. Okay? So this here, these are models. What do you guys think we use models? What is the significance of using them? Was that? Because I can't see with the naked eye. Can you guys see hydrogen with your eye? I mean, are you that good? I see that right there. I can, you know. So we have to use models to help us visualize things, right? And that's going to be kind of important. We want to be able to visualize. Okay. So do you guys have the distinction between a diatomic element and an element? Don't just nod to say nod. Don't nod to make me happy. It's not going to make me happy if you don't do well on the test. It's going to make me mad, right? I want you guys to do well on the test.
Diatomic is 2, right? It's
Diatomic is 2. Okay, that's right. Okay, so we know the difference. You can tell me if somebody gave me symbols like this.
Yeah, that's element, that's diatomic.
Okay, so now I'm going to work on something else. Okay, so we have, and you'll notice that I will stray from my lecture a little bit. That's on paper. That's why it's important for class, right? Okay,
So I have a question.
yes,
So all those are the only diatomic.
yes, only these 7.
Oh,
Yes,
the rest of
diatomic.
them are regular elements.
There, that is a very good question. So there are some other exceptions. There are two, right? And those are polyatomic, right? Poly, what's poly mean?
Multiple, right?
Multiple, that's right. Multiple. Okay, so there are two that are polyatomic. That's going to be sulfur and phosphorus. Okay. So these are both going to be examples of polyatomic. Now, sulfurs and phosphorus are kind of funny because it depends on their state and where they're found, whether they're going to be polyatomic or whether they're going to be monoatomic, right? Majority of the time, they're polyatomic. That's their natural state. They like to be poly, right? But occasionally, they will be monoatomic. Okay. So, we deal with diatomics. These guys are going to be polyatomic. They can be polyatomic. And everybody else falls in just the element category. Everybody else. Okay? Questions? That's a good question. Like, good questions. Okay, so let's talk about the next thing. Compound. Tell me if I'm off the screen. Okay. So a compound is going to be two or more. Right? Two or more different elements. Okay, two or more different elements bonded together. Okay, so you guys can do me a favor. Can you guys take out? You guys will either have a green ball that has one hole, or the hydrogen. Or it will be. Everyone was absolutely different case. You guys, one hole, I think yours is your yellow one. Okay, you guys don't have any rules. You have red with a single hole?
Yeah.
Okay, so use your red. Okay, well, we'll use the red. Red is oxygen, so red should be oxygen, all you guys. So red should have two holes. Does red have two holes? So do me a favor, take in your case, you take yellow. Take yellow and your red. What was that? Yeah. So yellow and red if you guys have the big box. If you guys have the long box, white and red. Okay. Okay, red stands for oxygen.
Is that like further state too?
No, just here and Salinas. Was that? Okay, so if you guys take a look, right? This here is an example of water, right? Because we know that water is H2O. Did I tell you white was hydrogen or yellow in your cases? Is that it? Feel both of them. Okay, so we have H2O, right? We know that water is H2O. Everybody knows that water is H2O. No, H2O, right? It's even on a, there's a water product called H2O, right? Okay, so this is an example of a compound, right? Why is it an example of a compound? Because it's two different elements, right? Two different elements. So that's how we would define a compound. Two different elements, okay, that are bonded together, okay? So two different elements that are bonded together. Okay. So if I had sugar, let's say you guys still have your hydrogen from the side. If we just had our hydrogen, right, and our water, right, and we put those together, right, that would be an example of what? Compound. So are they physically bonded together?
No.
They're not physically bonded together. So that would be an example of what? If I bubble hydrogen gas into my water, that would be an example of what? What was that? Someone say over here, a mixture, right? Or we would call it a solution, right? Okay, so we know that if we have two different compounds that are brought in together, we know that that's going to be a mixture that are not reacting with each other, right? And that's going to be the key. Okay, you guys with me so far?
Yes.
So far, if if there's doubt, it's okay, because the key is that I want to make sure that you guys are getting, right? So do me a favor. Your water and your hydrogen, right? Put them together. Are they connected? Can this guy go anywhere he wants to go? Can this guy go anywhere he wants to go? Right? So that's what happens in a solution. Even though that they're sharing the same space, we're just putting them in the glass together, right? So if I put you guys all in a group together, right? Are you guys all the same? Right? You guys are all different, right? So that's like putting four different elements that are together. That's going to be a solution, right? They're a solution, right? Okay. Now, if they were coupled up and they're interacting with each other, now that would be different. They would be bonded together. That would be a compound, right? Okay. Does that help a little bit? Can you guys see it? Okay. Okay. So I have one more thing. Then we're going to test out knowledge, right? We have knowledge. Two or more elements bonded together. Okay? Two or more elements bonded together. How's that different from a compound? Was that the question you're going to ask?
Yeah.
Okay, then I want you guys to tell me, right? How's that different? It doesn't say that they're different or not. So is this a molecule?
Yeah.
Okay, is it a compound? No. So this is not a compound
It's the same.
because it's the same. That's right. But it is a molecule. Is this a molecule? Yes, it is. Right? It is. It just says two or more elements. Isn't there two or more elements? There's 1, 2, 3, right? It has 3 elements. Does that meet the definition? Right. Okay, so you guys have just learned the difference between compound, element, and a molecule. Right? Now I'm going to put something on the board I want you to think about. Let's see. I only have one board that I could really use to show about. So, because we're chemists, we like to make things easier sometimes. So, I want you guys to tell me which picture best represents an element, a compound, or a element, compound, or a molecule, or diatomic. Okay. So, Okay. Okay, so this first box. What do you guys think that that's going to represent? Diatomic. Okay, it could be multiple things. So diatomic. What else? Molecule. Anything else? Okay. So we're going to say something else. Element, the diatomic element, it would still fall in the category as an element. So scared. It's okay. The best way of learning is being wrong, right? Did you guys learn? Like, okay, so how many of you guys put your hands on the stove as a kid? Anybody do that? Nobody? None of you. You guys are full of crap. You're telling me, I know I did. You did? Yeah. I had one person that did. How did I learn that the stove was hot? Right? I touched it. Mom would always tell me it was hot, but I had to find out myself, right? So, but I had to learn the hard way. I had to get that burn before it clicked, right? Was there, you guys, don't tell me you guys were perfect. You did anything bad as a kid? Anybody got whooping? You never got
I never got whooped in my life.
Are you serious?
I should have though.
I like that. That's honest.
I didn't get whooping about beat.
They got beat.
I didn't either.
Yes. But the thing is that we learn from our mistakes by making mistakes, right? If you don't make mistakes, you don't learn, right? You talked about your learning about this class, right? Right? You're like, well, I screwed up. She was upfront about it, right? We learn from our mistakes. You know, make mistakes. It's okay. It's better for you guys to make it here rather than in the hospital, or better for you guys to make it here now rather than on the exam. It's okay to be wrong. That's what we learn. Okay. Okay. B.
Element.
Element. Sure.
Well, you said it's.
Yeah, it's okay. Like I said, I'm just asking you.
Well, I'm gonna ask you, they all you said elements involved, right?
Elements are involved in everything, technically, but not everything's an element. Okay. Because an element basically means that it's a pure substance, right? Something that is pure. One type, right?
Compound.
So somebody said compound. Compound. But again, okay, to be wrong. Okay, compound. Anything else? Molecule. Can you guys see it? That and that, two different things, right? Two different elements, right? Making together that are interacting. Okay, what about C?
That is just
Element.
Element. What about?
Oh, diatomic.
Oh, sorry. What's that?
Mixture.
Oh, I like that. Somebody thought beyond that. Mixture. Good job. Okay. You guys saw that?
So just mixture only.
It's just a mixture only, right? Because it's mixing everything there, right? You guys, good job. Okay. So does that kind of help clarify that? Any questions?
That's a
If you guys, yeah, you think sure, whatever.
Make my notes. I have them here.
Here, you want me to photobomb it? Okay, so you guys have to talk. You guys either confirmation or I don't understand what you just said, right? Do you guys understand? Okay, good. Because if you don't tell me you understand, because I can finish 4 chapters in a day. I talk pretty fast.
I mean, the class will be short, short.
Oh yeah, it'll become real short. You may not pass, but it'll become real short, right? Okay, so we know that we have what we call chemical symbols, right? So that O, oxygen, represents that symbol, right? So when we have H2O, we know that that's going to be a chemical formula, right? Okay, that chemical formula tells us H2O. H2O. It says that I have 2 hydrogens. And we understand that there's going to be 1 oxygen. So anytime I see water, I know I have how many hydrogens and how many oxygens. Okay, so I know that it's always going to look like, here's my H2O. This is always going to look like that, right? 1 oxygen, 2 hydrogens. Okay, so that represents our chemical formula. So let me tell you about this. Everybody got this down, right? Yes. Take a picture. Don't be scared. Don't hurt yourself to try to make me happy. Everybody's good now? Good. And it's not disruptive. I like taking pictures. You know, I'm cute. What can I say? You know, so. So this is called the substrate. What's that? That number 2, yeah. That number 2. Number 2, so that is the substrate. That lets me know how many of the elements that it's behind that I have. Okay, so here we know that we have next to hydrogen, we have 2 hydrogens. And since there's not a 1 there, it's understood from you. Right? So then this means that there's 1 understood, we understand. Okay, so when we have the subscript on the outside of something that's in parentheses, that means that we have 2 of whatever in parentheses. So really, this means that I have 2 of those. I technically have attached to that magnesium. Okay. So that means I have 2 of these that are going to be attached to this. That's going to be bonding to this. Okay. So if I ask you how many total oxygens I have, how many total oxygens do I have? Solid has 6 oxygens. Okay, how many chlorines do I have? And how many magnesiums do I have?
You don't put it, it's not gonna be 10.
It's not good, it's 1, because it's only next to the one that's next, right? So it would be 1 magnesium. You guys see that? Oh, sorry. Again, it's a work in progress.
So I have a question.
Yes,
I don't know. I thought right here I was like, do like the cross. But, you know what I'm talking about?
balance it.
Yeah,
We'll get to there. We'll get to that. That's a little bit along, a little bit further.
okay,
First,
I
gotta
was just
get
making
to-
sure because I
Yeah.
remember.
Okay, so we have 1 magnesium, 6 oxygens, and 2 chlorines. Okay, so that compound acting all together, it's one compound that has all of this. Okay. Okay, so subscripts lets us know how many that we have. And it's going to be next to the element, right? That it's referring to. Let's say, so if I have this is hydrogen peroxide. Okay. So how many hydrogens do I have in hydrogen peroxide?
2.
How many oxygens do I have in hydrogen peroxide? Simple, right? Okay. Say I have this. Okay. How many sodiums? Na is sodium. How many phosphorus?
1.
What?
One.
1. There's nothing next to it, right? So there's just 1. And then how many oxygens? Okay. Straightforward. Okay. Okay, so the state of matter. So, you guys know the states of matter? Solid, liquids, and gas. Those who are really into science also know there's plasma. We won't talk about plasma, we're going to keep the solids, liquid, and gas. Okay, we're in certain states. Okay, so okay, how many of you guys have boiled water?
What?
Boiled water. Nobody? Okay. Everybody's boiled water. Good. Okay. So when you boil water, what happens? It gets hot, and what happens to it? It starts to bubble, and then what happens to it? It evaporates. So if I let it keep boiling, will I have any water in my pan? What happened to it?
It'll burn, it'll go and evaporate, right?
It'll evaporate. Okay, so, but is it still water?
It's gone.
Yes.
It's still water, then it's changed into what? A gas. So you're telling me liquid can go to gas. Am I changing the chemical composition of water when it goes to gas?
Yeah.
You don't know. Are you sure? Can't you collect it? Like, so have you guys ever put a lid on top of it? Right? What happens when all of the steam goes up on top of the lid? What?
Condensation.
Condensation, which means that you're going from a gas back to a liquid, right? Okay, so the state from going from a gas to a liquid, we know that that's called condensation, right? Okay, condensation. So it's going from a gas back to a liquid. Okay, the process of going from a liquid to a gas is called what? You said evaporation. Okay. So going from a solid to a liquid,
Melting.
melting. Going from a liquid to a solid, freezing. Going from a gas to a solid. Gas to a solid? No? It's called deposition. Going from a solid to a gas. There's a band named after. That's the gas. I guess it would be sublimation. Okay, so it's dry. Okay. Okay. So these are all considered physical states, right? So if I'm going from a solid to a gas, or from a gas to a solid, that's going to take either energy being put into the system or energy being released by the system, right? It all involves energy, right? So we get from water, I mean, a liquid to a gas. Get through that. We got to heat it up, right? So when we're talking about chemistry, a lot of chemistry is going to be associated with heating things up. So it's going to be associated with heat. How do you guys think of heat?
Energy.
Energy. That's right. Heat is energy, right? Because you got to put energy in it to sit there and get it to go up from that temperature that it's at to the temperature that we want it to, right? How many of you guys run the AC in the sun? Most of us run the AC in the sun. Does that happen for free? Because you guys see that bill, right? Right? That bill. So cooling things down can also take energy, right? So we have to put energy into the system to make these things happen. Okay, so energy is going to be a key component to it. Okay, now what's happening to that solid? Let's say, for instance, we have a block of ice, right? That ice becomes water if we just let it sit on the table in a warm room, right? Okay, so what's happening to those molecules of H2O?
They're speeding up.
They're what?
Speeding up.
They're speeding up. So when we think about ice, ice is kind of like really organized. It's very structured, and all the molecules are very tightly packed for a certain realm. They're like perfect, right? Now, the thing about water that's kind of funky is that it's so organized that it leaves these little gaps that air could actually get into, which makes ice cubes float, right? Because you have those little gaps between them because they're so nicely organized, perfectly organized. So initially, everything is kind of like this, very rigid, and because if we look at a block of ice, it's a block of ice, moving around and stuff like that. But you guys have your water here, the model. Hey, I have my water here, right? Look at that. Is that very rigid? Right? It moves freely and everything like that. It just goes to the volume that we're putting in, right? Where a block of ice, if I have a block, it's already a block, and I fit that in a circle, right? If I let it melt long enough, it will be able to, but no, I can't, right? That block of ice can't be fit into that circle, right? It doesn't have that flexibility set, rigid, right? And so you told me that it's moving, right? So those molecules are moving. So that block of ice is like this. It's like you guys been to a party, dance party where it's just packed. I mean, it's just so packed, right? And then you're just like this, when you're dancing, you're like, because you can't move because there's so many people there, right? Anybody been to a party like that? A house party or nightclub? Okay. So, but you also went to a party where, they have maybe one or two friends and you have the whole dance floor to yourself, right? That's kind of like gases, right? Because then you can do whatever you want to do. You can move, right? You can sit there, kick it over here, kick it over here. It's no big deal, right? Okay, exactly. Yeah, so you have all the room in the world.
You
So-
parked a lot in college? Look at it.
I'm a strong believer in I work hard, I play hard, right? I got an A on an exam, you want to bet your ass I'm gonna be out partying, right? Work hard, play hard. Now, if I didn't get an A on the exam, I asked to study, right? That's the way I was raised. You work hard, you play hard, right? So you work hard for that money you get, you spend it the way you want to, right? So that's my philosophy. But anyway, back to this, right? So it's about motion, kinetics, movement, right? So what's happening between those molecules when it's frozen, they're going to be very rigid. They're not going to be moving as much, right? They're going to move in a little bit, right? It's not at absolute zero. At absolute zero, nothing moves. Everything stops. Life stops. Nothing moves. But if it's frozen, we still get some movement. Water, we have a lot more movement, right? We're able to get it to move, and it moves nice and freely. And gases are like bouncing off the walls and everything, right? So the difference between them is that movement, that kinetics. So this gives us this theory. It's called the kinetic molecular theory. Basically, it says that molecules do what? Move, right? Kinetics basically move. Kinesiology. Anybody studying kinesiology? I don't think you have it. One. Okay, so yeah, kinesiology means the study of movement, right? That's what it really means, right? Everybody thinks of it as physical therapy and everything like that. Well, guess what you're doing? You're studying how muscles move, right? Kinesiology, right? They also associate it with PE, right? Because you're studying how muscles move, right? Okay, so kinesiology means movement. Kinetics means movement. Okay, that motion. Okay, so as temperature increases, we expect what to happen to the molecule. We expect Guillermo to happen to the molecule. We'll put it like this. Well, let me give you a situation. So we decide we're going to go to Costa Rica. Right? Go to Costa Rica. 4 years ago, I went to Costa Rica, and it was beautiful, very beautiful. But it was hotter than fucking hell, right? And I get on the beach, and I'm like, and I don't know what I was thinking, and I forgot my flip flops, right? I get on that sand. What happened as soon as I got on that sand? It was burning my toes. So what do you think I did? Did you think I just swaggered to the water? Or do you think I ran to
I
the water?
need to the
Right?
water.
Why did I run to the water?
Because that was hot.
Well, my feet were burning, right? So heat makes us move, right? We want to move to somewhere that is cold. So the molecule is going to do the same thing. It's going to move. As we put heat into it, it's going to move faster, right? Gases move faster the more heat we put in. Does that make sense? So we want to think about things kind of like how we think about it, right? If you think about it like that, right? You think about it, don't think of them as being abstract, because guess what you're made of? Yeah.
Molecules.
Molecules. You're made up of molecules, elements and molecules. So, and not just you, everybody in this room. Don't think you're special. Okay, so you guys getting it? So, if I want to speed up a reaction, what do you think I'm going to do? I'm going to heat it up, right? So if I want ice to melt, am I just going to sit there and watch it melt? Or am I going to
Warm it up.
warm it up, right? Okay. So okay, so before we get too much into this, we talked about water. So we also said that it doesn't change the physical state of water, right? So we know chemically it's still H2O, whether it's a solid, liquid, or gas, it's still water. So we didn't change that state. So that's a physical reaction, right? So the changes from state is a physical reaction. It takes energy to do that, right? Energy is required to do that. And so the way that we would sit there and define that as that change in state, we often use enthalpy. Guys, this term, enthalpy, earlier. Okay, so enthalpy just basically kind of means heat, right? So it's either a heat of a reaction or the heat of changing states. Okay, and the way that you'll see it represented as, you got to excuse my third grade handwriting, delta H. So if it's evaporation or vapor, it would be called delta H vap or vapor. Okay. If it's melting, then you would call it delta H melting, or they also would call it fusion. Okay, delta H just means change in enthalpy. And the way it's usually measured is you take the quantity that you have of that molecule and you multiply it by a value, a constant value. Okay. We'll talk more about that a little bit later. I just wanted to introduce you to the term now, so you guys get associated with looking at delta H, meaning heat. Okay. Energy. Everybody got that down? Okay, so let's talk a little bit more about it. So when we talk about solids, there are two types of solids. One is called a crystalline solid. Right? Crystalline is basically organized. It's a very defined pattern, right? You guys like order, you realize things to be organized and structured and everything like that. So that's kind of crystalline. Amorphous means that there's all different shape. It doesn't have any type of pattern or anything like that. How many of you guys are into sci-fi? Yeah. Shapeshifters are considered amorphous, right? So meaning that they can change shape, they lack a common shape. They can change shape. So if it doesn't have order, it's going to be amorphous. Okay, this is just talking about 3 different states. So the shape of gas, it just kind of depends on that container, right? And it's going to be very variable, right? So the shape of a liquid, it's going to be variable. It's going to be dependent on the bottom of the container. Right? If it's solid, it's going to be rigid and fixed. Okay, in terms of the volume. Well, the volume is going to be dependent on your container if it's a gas. Okay? Because it's moving, right? It's constantly moving. In the case of a liquid, it's going to have a constant volume, right? We have a certain volume that's associated with a 2-liter bottle of soda. 2 liters is volume. So what is the volume of a 2-liter bottle of soda? 2 liters, right? Okay, so that's a constant value. We know that if I'm buying a 2-liter bottle of soda, guess how much soda I'm expecting to have in there? 2 liters, right? And if there isn't 2 liters, then you're going to the store and saying, where the hell are my 2 liters, right? Okay. If it's a solid, it's also going to have a constant volume associated with it, right? We know that if it's a square block, let's say it's a cube, and it's a 2 by 2 by 2 cube, right? Cube. All sides are the same. So how would I calculate that volume? Say it was 2 inches. 2 by 2 by 2. You guys remember that? By like over here. Right. What was that?
Length times width.
Length times width times height. You guys can see my artistic skills. Not fixed. 2 by 2 by 2, right? So you said it's length times width times height. And that's going to be 2 times 2 times 2, all inches. Okay. So it's cubed, right? That would be the volume. So we can calculate the volume of a cube, right? Impressive, right? So an ice cube, we know that it's going to be a cube. And if it's a 2 by 2 by 2 ice cube, then we know that it's 8 inches cubed, right? That represents that volume. Okay. So knowing that, what the hell is volume? What does that mean? I want to take a guess. It is a measurement, that's true. Okay, let's elaborate a little bit more with the measurement. Is it mass? Is it mass? Is that really, is it weight? Do you put it on a scale and say, oh, that's 25 grams? Oh, somebody said it here? I heard, wait. It is the space. It is the space that's being occupied. Guess what? That's 2 by 2 by 2. That space is being occupied. Volume represents space, right? Space being occupied. Okay, good. You guys are thinking about it, right? We know that when we talk about volume, volume is one of those things that we're going to be talking about in chemistry all the time. And that just represents space occupied. We talk about mass. Mass. Everything has mass. Didn't I say that earlier? Everything has mass, right? The smallest thing has mass. What is mass? What was it? It's the weight. We often will associate it with the weight. You're going to say something else? Well, there's a distinction between mass and weight. They're similar. What was that? Amount. Quantity. You're saying it's quantity? Well, you were going to say something else. Say something else. Don't be scared. Okay, what did I say about you?
I really don't have it.
Oh, okay. Anybody want to add to it? Mass. Mass.
The amount, right?
Is it the amount? Because amount would suggest quantity, right? Is that true? Like, if I say I have 25 apples, does that mean my apples weigh 25? So mass is its own type of unit. It's what we use, like I said, it's weight, right? We put it on a scale and we say, okay, an apple weighs, 5 kilograms. 100 grams, right? So then we would say an apple will weigh 100 grams based upon that scale. So mass is a unit of measurement for, like we say, weight. But the difference between mass and weight is mass is uniform, regardless of where you're at. So if you're on the moon, it's going to be the same. The
So
weight
this
is
the
going to be,
periodic table was never the mass, right?
it gives us the atomic mass. We'll talk about that here in a minute. That's actually a good point. We'll talk about this distinction, right? And it's based upon carbon, right? Mass has been based upon carbon atoms. But everything that we've done, its weight and everything is based upon that carbon atom, centralized respiration. And we'll talk more about that here in a second. Not quite yet. It's our third lecture. You guys get ahead of the game. I like that. Okay, so mass and weight are similar. The only thing that's different between mass and weight is that weight is dependent on gravity. So you will weigh differently on the moon than you would weigh here on Earth, where the mass is going to be uniform on all cases. So we use grams as determining mass, right? And weight, you can weigh pounds or grams, all that. Okay. Questions? And let me erase some of this because it's been kind of crazy.
Isn't there like something else like the area of it?
The area, yeah. So we do have the area of a, let's say, a surface. Like for instance, if we just look at the outside of this book, right? That would represent the area, right? And that becomes really important when we're talking about reactions, right? Because if we're working with a solid, something that's solid, let's say we had a solid piece of metal and we stuck it into a solution, and we say that solution is going to react with that metal. Well, guess what it's going to react with? Is it going to react with the whole metal, or is it just going to react with the surface? The surface. So then the area comes into play. Let's talk about area, since you brought that up. Area, what is the, how will we calculate the area? We start simple, a square.
Yeah, based on
Length times width.
it's based on
Based on
height.
Okay, so it's length and height, right?
Yeah.
So, and height. Okay, so if we're talking about the book, right? It has 4 different spots, right? So if we think about that book, right, it has this one, that face. It's easy for you guys to see the book. Okay, we have this face here, we have this face here, we have this face here, 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 and here. So it has a total of how many faces? 1, 2, 3, 4, 5, 6. So we have to take all of those in consideration when we talk about its surface area. Okay, that would be the surface area of the book. So what we do is we add up all of the surface areas, right? And so it's you guys probably won't get into that much detail, my 1A class, general chemistry, because they need to define how reactions are going to behave, right? They would have to get into that detail. Right? In most cases, what we're going to be doing, we're going to be adding 2 solutions together. Occasionally, it'll be a metal, and you'll see that the metal will react slower than when we add the solutions. Does that make sense? Give or take? Yeah, have a look. You're thinking. Okay. So let me see if I can define it a different way. Okay. So I have my box. Now, this is all plastic, right? You guys, acetone, you know, polish remover. Right? So acetone will actually destroy polystyrene. You guys know what polystyrene is? The coffee cups, those foam coffee cups, that's polystyrene. Okay, so it'll actually dissolve. So let's assume that this was made entirely of polystyrene. Okay, now I stuck this into acetone, you know, polish remover, right? So, and let's say this whole thing was polystyrene. Is it going to destroy the stuff that's in the middle, or is it just going to destroy the stuff on the surface? Okay, so it's only going to destroy the stuff on the surface because it's not going to get a chance to get to the middle until it gets to that surface. Okay, so those are the things that we think about in terms of chemical reactions. It limits those reactions, right? Because the way what we're using can limit how something is going to behave. You know? And so often, if you're going to be a chemist or if you're going to be an engineer, you have to take into consideration how you're going to use things because it can really fuck up your reactions. It's kind of like if you're giving a patient drugs, you give them a tablet, you give them a liquid, or you give them a, you know, a stimulant. So all of that is going to be dependent, right? Because if you want it to be some response, right, you don't want it to react really fast. Guess what you're probably going to give them? You're going to give them a hard ass tablet, right? That dissolves slowly and stuff like that. And so then that way it's reacting slowly throughout the body, right? But you want something that's going to react instantly. What are you going to do? Are you going to give them an injection? You're going to give them
Give an injection.
Give them an injection, right? Right? Because you know it's already a liquid, it's going to hit the bloodstream pretty fast. It's going to happen pretty fast, right? And so those are all of the things that we think about as healthcare providers or as scientists. So those are things that we want to take into consideration. Does that make it a little bit clearer? Okay, so that means that we've talked about physical change, right? If we're going from state to state to state, that's just physical because we're not changing the chemical components, right? Now, a chemical change is different. So we talked about cooking, right? I like to make caramels, right? Now, I had to make some special caramels once, you know, friends gave me some extract and stuff like that. And I told me, I'll hook you up with some caramels, right? And at the same time, I was trying to do some other things in the background and probably had a little too much of that special sauce itself. It didn't help out any at all, right? So I forgot that I was actually cooking, right? And guess what happens to sugar when you put it on the stove? It burns. It actually burns, right? The process, sucrose. Let me give you guys the chemical formula for sucrose. Oops. And then I want you guys to help me out. C12. H22. Okay. So C12, H22, O11. How many carbons is that? That's 12 carbons. How many hydrogens do I have? 22. And how many oxygens? Okay. On the other side of the reaction, I'm going to get carbon and water. Carbon. Carbon, we know there's just an element by itself. Carbon. So I'm actually going to go over here and then we're going to work on the board. Let's stop. So yeah, see? H22. H2. Okay, so we know those subscripts, right? Now, this here is a chemical equation. This is what we call an unbalanced. Okay. So what it means is that although it's a chemical equation, it's not right. We need to fix it, right? Let me show you how to fix it. There's a law. It's called the law of conservation. Law of conservation and law of conservation of mass specifically says what you put in, you must get out, right? So in terms of mass, if you put in a mass, you have to end up with that mass. It can be in different forms, but at the end of the day, what you put in, you got to get out. In terms of quantity, what you put in, you have to get out, right? That's just the way it works. Like if you put in $10, you expect to get $10 out of it, right? At least, right? Okay. So the way that we account for things is that we break it down. How many carbons are we putting in? We're putting in 12 carbons. Right now, over here, how many carbons do we have? One. How many hydrogens? 22. And then over here, how many hydrogens? 2. How many oxygens? And then over here, how many oxygens? Okay. Did we put in what we got out? That means that we have to play with what's called the coefficient. Coefficient will be the number that will be in front of that chemical compound. Okay. So we put numbers in front of it to help us balance the chemical equation. Okay. So we want to get what we put in, right? Out. And or what we got out, we put in. Okay. So let me give you an opportunity. How many carbons do I need?
12.
I need 12, right? I have 12 here, I have 1 here. So what coefficient can I put in front of that carbon to make it 12? 12. 12 here, now. Okay. What can I put in front of water? 11. Okay. 11 times 2, 22. 11 times 1, 11. Does that work out? Okay. Now, this is called a balanced chemical equation. So here are the rules. Once you have the chemical formula, and you know the chemical formulas are correct, that's what you're doing at this stage, the chemical formulas are going to be correct. Okay. Then what you need to do is work with the coefficients, numbers that would go in front. Now, these numbers represent how many of that particular element or compound or molecule. Okay? So this lets us know that there are 12 carbons that are going to be made from this. And we have 11 waters. So this number here times this entire thing. Okay. How are you guys doing so far? You guys got it? Okay. Now, this is an example of a chemical reaction. The reason why it's an example of a chemical reaction is because we started out with sucrose. This was sucrose. And then what we got out of it was carbon and water, which is no longer sucrose, right? Is sugar the same thing as burnt ash
No.
at the end, right? It is not the same thing, right? So after I got through cooking, I had burnt ash at the end, right? Now, I mean, I cooked it to a pulp. It was literally, and actually, that was almost an example of exactly what I did on the screen earlier, right? So totally cooked to a pulp, right? I can't get it back, right? Can I make sugar from my burnt ash? I can't, right? So I can't get it back, right? So that's an example of a chemical change. Okay, so I went from something that was really nice and sweet, tasty, to something that was. Have you guys ever ate coal, like as a kid or something like that? Tried chewing on coal or brush your teeth with coal toothpaste or
Yeah.
charcoal toothpaste? How does it taste? Charcoal toothpaste tastes good?
Well, no, like,
It feels good. I mean,
Yeah.
it feels good, but does it taste good? Have you guys, I mean, I ate
well, the
charcoal.
Colgate one.
I was a kid. I mean, my philosophy was I ate sticks, I ate
remember all
everything.
this
We gotta
stuff.
try
I
stuff,
remember
right?
all this stuff.
You know, I'm a strong believer. You gotta try it once, and then once you really realize it, then okay, that didn't quite work out. Right? So, you guys ever ate yarn or anything like that?
I used to eat flowers.
Well, I learned that real quick. Ate yarn and okay, but the moral of the story is that when we leave it in, we gotta get out. And this is called balancing chemical equations. It's really important. It's one of the things that you need to know how to do. So if you don't get it, let me know. If you guys want to try another.
You gotta show us that one time, that's it?
One and done. You guys, it's one time. That's it.
That's the hard, you know?
So I'm asking you, I just asked you, what did I just ask you?
Well, yeah, do another one.
Okay, that's what I said. You guys want another. Because sometimes people get it the first time. Sometimes people, it takes a couple of times, and then sometimes people just like, don't want to get it, right? You guys, you control your own fate, right?
You just know that's gonna be on the test.
There are a lot of them that are gonna be on the test. You're gonna see this the rest of your life. Okay, so let's do. All right. Right, yours.
Yeah.
Okay. This is called a combustion reaction.
Those are horrible.
Yep, I understand. How are we? I know you just said. How are we able to make that?
It's already happened, right? It happens with reaction actually, but you're just accounting for it. It's kind of like, you know, people at the end of the day, they give you money for, let's say, products that they bought. At the end of the day, you have to make sure that all that money adds up, right? They did already give you the money. So in the reaction already happened. Now you just gotta make sure everything adds up. So that's what it is. But that's actually a good question.
You just said, no, that's what we want.
No, you're trying to make sure that it counts. It has to add up. And that's what the chemical equation does, so taking into account. It's like, it's really.
Already happened. The equation itself is shown.
Exactly.
You're double checking your work.
Exactly, yes. Yep. Okay. So, first thing that I did was to do what?
I know what we have.
Find out what we have. So, what are the different elements that we're working with?
Carbon, hydrogen, and oxygen.
Okay, so we have carbon, hydrogen, and oxygen. Okay? This is called our reactant. The active side. Okay, these are things that are going to be reactive to make what we want. This is called our product side. Okay, so how many carbons do we have on our reactant side?
2.
Okay. How many hydrogens do we have? And how many oxygens do we have? Still moving more time. How many?
2.
And then on the other side, on the product side.
1.
Hydrogen. 2. And oxygen. 3, because we got 2 here and 1 here. Is it balanced? No. Oh. Okay, so where should we start? Start on the product side. So what should I add on the product side?
And to
So I want to get carbon to 2. So I'm going to start here. 2 times 1. So how many oxygens do I have? 2 times 2 is 4 plus 1. So that's 5. Okay. Everybody see that? Anybody not see that? Yeah. So and if you know, you can take a couple times to get there. Right? But you'll get there. Okay. So is it balanced? No. Okay. So what about the hydrogen? So if we put a 3 in front of the water, 3 times 2.
6.
So then that gives me how many oxygens here?
7.
So it's a total of 7. No. But my carbons are balanced, are they not? My hydrogens are balanced. It's just my oxygens. Let me look over here. What can I multiply and get 7? 7 over 2, you said?
Because you have to put parentheses and put the 2 on the outside, right?
No, you can't change this, right? So you're saying if I have 7 over 2,
No, you're gonna.
can I do that? Doesn't 7 halves times 2? Does that equal 7?
No.
7 halves? Oh, let's do this. 7 over 2 times 2.
Oh, yeah, it's gonna cost 7.
Right? That's going to equal 7. Is that not?
Yes.
Anybody disagree? It's okay, you can disagree. I'll tell you you're wrong, but you can disagree, and we'll show you how to get to that part. Okay, so we know that half. Now here's the question. Tina. So if I took Tina and I cut Tina in half, is Tina going to be okay?
No.
No, Tina's not going to be okay if I cut her in half. So if I took a molecule, I only one molecule, and I cut it in half, that molecule isn't going to be okay, right? But I can use that to get me to my next level, right? Where I want it. What can I multiply a half by so I can get whole?
7.
By what? What's that number?
2, right?
By 2. So if I multiply this whole equation by 2, that gets rid of my half, right? And I have a whole number. Cos 2 times 7 halves is what? 7. So at the end of the day, I get 2 times, this is going to be 1, 2, 6 plus. I'm going to erase this part. Two times 2, 4. 2 times 6. I mean, 2 times 3 is 6.
6.
Okay, now we want to confirm it, right? Because you want to make sure that your answer is right. You want to just crap, right? So let's go through and confirm it. So we know we have hydrogens, we have oxygens, and we have carbons. Okay, so how many carbons do I have?
4.
How many hydrogens? How many oxygens? Somebody other than the people that are saying it. 7 times 2.
14.
14. Okay, over here. How many carbons?
4.
How many oxygens? 8 plus
12.
8 plus 6.
14.
Okay, 6 times 2. Does that work out?
Yeah.
4, 12, 14. Okay, you guys got that? So we went from like first to like 5th year, right? That's okay, don't worry about it. You got it. You want to do one more just in case?
Yeah.
And then we'll take a break. How about that? Everybody got a picture of this? Picture.
This is where I did 14. So is that what combustion you're gonna times it by 2? Or is that?
No.
multiple?
It's not always, you can't make that assumption.
No, I'm
right?
just asking.
Yeah, no, that's no, it's a good question, but I'm saying that you can't make that assumption. It's okay to ask. You can't make that assumption, just depends on the question. Very much. I'll tell you a little secret how to figure it out. Typically, if this number is an even number, you're always gonna have having to do it. If this number is an odd number,
But is that only?
but if you're coming with the combustion reaction, it's not always gonna be the case with combustion.
Those are the hardest that one stop, right?
There's some that are. Okay, you guys are ready? Ready for the next one? And just quick break.
You're, I think you're right.
Let me shift.
Just shorten the equation. No, I'm just kidding.
Pieces of equipment, I'm still learning what I can and cannot. Okay, so we're gonna go about this 2 different ways. I'll show you the long way first, then I'll show you. So, they appreciate each other. Okay, so first off, is it balanced? Okay, so what are the elements I have here?
Magnesium.
And if you don't know these names yet, check your periodic table. It's always good to have it out there. Okay, so how many sodiums do I have on my reactant side?
3.
How many phosphorus do I have on my reactant side?
1.
How many magnesium do I have on my reactant side?
1.
How many sulfur do I have on my reactant side?
1.
And how many oxidants? Okay, on the other side, how many sodiums? How many phosphorus?
2.
Okay, how many magnesiums?
3.
How many sulfurs?
1.
And how many oxidants? Okay, so we have 8 here, plus 4. Okay. Start off with something easy first. Okay, is there anything that's already balanced?
Sulfur.
Sulfur's already balanced. So how can I balance my phosphorus?
2.
Put it to where?
In front of the NH3, right?
Na3 on the product side or the reactant side?
The reactant side.
On the reactant side. So you're saying put it 2 here? Here?
I think so.
Okay. So if we put a 2 there, that gives me how many sodiums? So we have 2 times 3. Okay, how many phosphorus?
2.
How many oxygens?
8.
8 plus. Okay. So, we're good. Everybody happy
So far.
so far? Okay. Anything else we need to do?
That's.
No, it's not easy. Okay, bless you. How many magnesiums do I have? 1 and 3. So how can I balance it?
I think 3.
Put a 3 where?
In front of the.
On the reactant side or on the product side?
Reactant.
3 here. So 3 magnesiums here. How many sulfurs do we have?
3.
And how many oxidants? 3 times 4, 12 plus 8, 20. Okay, are we good? Balanced?
Almost.
Almost. Okay, so I have how many sodiums? I have 6 over here, but I have 2 over here. How do I fix it?
Product side.
You gotta have 3.
Okay, so you said add a, what?
3 in front of sodium on the product side.
Okay, so I'm gonna put 3 here. Okay, so then that's 3 times 2. 3 times 1. And 3 times 12.
You said the answer.
So 3 times 4, 12. 8 plus. How many came over here? 8. 8 plus 12.
20.
Is that balanced?
Yeah.
Okay, take a picture, then we'll take a break. Take a 15-minute break. Then we'll come back and, you guys got this. You don't need me to do another one, do you?
I need another.
You need another one? Okay. So we'll do one more when you guys get back.
Let's make it easy.
Huh? I want you to be ready for the real world, right? Okay.
And then order ahead. You're gonna be eating
Okay, so I'm gonna give you guys an opportunity to get started on this one. Can you guys see it?
So that's down for down the lecture part, right?
Oh, we're almost done. That is the best part about being.
So what type of reaction is this?
This is also a combustion reaction, but this is also a very famous reaction. Anybody took bio? Any bio? Actually, if you took any bio, you should know this chemical equation.
Is it bad that you, like, when you take a class, you don't remember that?
Yes, it is very bad. Yes. Yeah, that is the one thing that you should remember from this. You will remember something, right? And there'll be one thing that you will remember.
Because sometimes I don't even know how I made it this far.
Only things I remember anatomy. Every time we hit our bones.
Because the thing is, the thing that you want to remember about chemistry, what you guys learned at the very beginning, is something that you're going to be using throughout the entire semester. So it is going to be consistently building on itself, right? So it's just going to be more and more and more and more. So you're not going to have like the traditional midterm and then you can dump everything out, because I know that a lot of you guys, I remember when I was in school, you study for the exam, and then as soon as you finish with that exam, you go do this, dump it all out, and then you're like, okay, now I got room for more stuff. Well, you can't do that with chemistry. You got to keep going. Everything that you learn, there's going to be more to it. It's that next level, right? Okay, so that's going to be important. Okay, so you guys got this worked out. I don't even have to get up here or do anything.
You never told me.
I'm gonna let you guys get up here.
What is it?
What's that?
You never told us.
I'm not gonna tell you. You're gonna tell me. You guys took bio. Somebody who took bio. Who took bio?
I
Who
don't
took bio?
remember that.
Anybody else took bio?
I did in high school.
You took it in high, you should know it.
I know it's
You took it in
carbon
high school.
dioxide, carbon and not actually that last.
That's it, anatomy.
You should know it if you took anatomy.
I tried, but I can't remember the name.
I'm sure she did.
It's
You gonna put
carbon,
money on
water,
it?
and
Who's the teacher?
She's from
Lamar. I'm gonna talk to Amy, but I'm pretty sure she did.
so much money.
How many of you guys breathe? Anybody breathe?
breathe.
Breathe.
Yeah.
Do you breathe? You don't breathe?
Dioxide?
Yeah.
I would hope that you guys all raise your hand. You guys all breathe, right?
But my watch reminds me to breathe all the time. So probably not.
Well, that's what you're making carbon dioxide. Okay, but when you breathe, what are you doing? You're taking in what?
Oxygen.
Oh, you're taking in oxygen. O2, oxygen, right? Okay, that's oxygen. And then you breathe out what? Carbon dioxide. That's called what? That process of breathing is called. Come on. Not expiration. Expiration means that things perish.
Yeah.
Or they.
Inspiration.
Not ventilation.
Inhale, exhale.
What was it? What did you say?
No.
Come on, say it. What did you say?
Let me look at my
It's something with an I. Oh,
You're close. You're in the ballpark, but it's not inhalation. Not inhalation. Well, that's breathing out, but there's the whole process
Ask the question
of us breathing in and breathing out, right?
Inhale,
What?
exhale.
Say it again.
Respiration.
Say it louder.
Respiration.
Respiration.
Oh,
So
I knew
this
that.
is a chemical formula for cellular respiration. How many of you guys eat turkey on Thanksgiving?
It's too dry.
It's too dry. It's too dry. Do you eat cakes and sweets and all that stuff for Thanksgiving? Okay,
No.
so have you guys ever noticed, Thanksgiving especially, you know, you go in, you're gonna button your belt a little bit, right? Because you're gonna chow down, right? You're gonna get greedy, right? And then you go. Right? You have to take those deep breaths, right? Why do you guys think you have to take those deep breaths? Well, it's not only because you can't breathe. There's reasons why, right? Because that oxygen is needed to break down the food. Oxygen is needed to break down that sugar that you're putting in. It's needed to break down that protein. This process is called cellular respiration. That very first chemical, this is called glucose. This is the foundation of all of our food. We kind of break it down so that it is glucose. Glucose is what we like, our body likes, right? So we get right? So those cakes, those pies, that turkey, right? It gets broken down to glucose, right? Or some form close to glucose. We need that oxygen to help with that process. And then as a result of that, we get carbon dioxide, we blow out carbon dioxide. We have to go tinkle, right? Water, heat, right? And then we get what we call ATP. ATP is form of cellular energy, right? And so these are just potential energy that our cells need. We actually get 32 total ATP, right? There's a couple that we lose and gain, and it always adds up to about 32, okay? So from one glucose molecule, one little molecule, we get this much energy, right? Now, this is called cellular respiration. If you took in any form of biology, you talked about your muscles, right? Muscles need ATP, right? You've talked about cellular respiration. Probably don't remember it, but you talked about it, right? If you talked about bacteria, guess what they do? They go through cellular respiration. If you're working on physiology, guess what you're going to be talking about? Cellular respiration. So this is happening at the cellular level, but it also affects the muscles and the tissues that we talk about. Right? Okay, so this is the basis of that reaction. This is just extra. It's all about energy. Okay, so we're going to take this out of it right now. So let's balance this chemical equation. Any volunteers? Or does somebody have to be voluntold? I'm good at that.
I think that onions are better, right?
Ready? Yeah, you're gonna have to explain it though. You can't just get up here and write up.
Oh, no.
Okay, so this is what we'll do. So.
Like, you mean like, yeah, we can get up there next month.
Well, we're gonna go through the process.
So we just can't just write the answer.
No, you gotta explain it, right? You wanna explain it. Okay, so what we're gonna do, we're gonna have you, and you. You guys are gonna go up there. You guys are gonna work as a team and explain it. Okay? I love it.
Who's that person?
Hello.
Yeah, so plus I and.
Okay, so we have carbon. So this side we have carbons. Well,
You gotta be able to hear you.
we have 6 carbons on the reactant side. We have 12 hydrogens on the reactant side. We have 8 oxygen on the reactant side. And when it goes to the product side, we have
Now let's give somebody else an opportunity. What do we have on the product side? 1 carbon. 3 oxygen. Is it balanced?
No, it's not balanced.
Okay, so where should we start at?
We're gonna start on the product side.
No, I'm not, don't
Okay, so we're
let
gonna
my
start on the,
expression
we're
say
gonna
you.
start on the product side right here. We're gonna balance carbon, so we're gonna add 6 carbons. So now we make this 6, so that's balanced. And then, where do you go?
No, you gotta get up there, get in there, get in the mix. So how many oxygens do we have?
Yeah,
The first one.
We have how many oxygens? Well, you just told me you put a 6 up there, right?
yes.
So how many?
You gotta count, I think. So it's 6 times 2 is 12. So it's 13 oxygen.
Okay, you see that? If you don't see it, you can't tell me it, okay?
Well, I see it.
I know you see it. But you see it. You have to see it too. You guys are working as a group. If you don't see it, you gotta explain it.
So 6 times 2 is 12, right? And then you got 1 right here, so that's 13 oxygen.
Okay.
So then you have to balance the nitrogen. There's 12 right here, that's 2. So what times 2 will give you 12? So you put 6 right here. Then you're gonna have to add, now you have to go to 12 right there. You have to recalculate that. Yeah. You have to, yeah. You have 6 oxygen right here, and then you have 12. So everything's here and whatever. 18 So the question is, what 6 times?
Because it has to, what you put in, it has to have. And so, once you have the chemical compounds, right, which is already given, in this case, these are already given, right? So, coefficient is making reference to the whole molecule.
Did you guys understand that? I don't know.
That's right, we'll have to see, we'll talk about it real quick. Let me borrow this. Good job, guys, thank you. Okay, so the question is, there's a couple of questions that some of you guys are asking. One of the questions is, how do you know I need to add something? Well, first off, I'm giving you the compound, right? I'm telling you you're having this compound and this compound, or this compound and this molecule reacting with each other, right? I'm giving you that. That's going to be given to you. We know that that happens in real life, right? You breathe, right? And you eat sugar, right? Okay. And then as a result of you eating sugar, you blow out carbon dioxide, and you got a little tinkle every once in a while, right? Or you make water, right? Okay. So that is the reaction. And once you know the reaction, you know the players, right? These are the players. Now is to try to figure out how many of each of the players you have. Okay? And so this lets us know that there's only one, because this is understood to have one glucose molecule. This lets us know that we have 6 oxygen gases. So for every one glucose molecule, I need 6 oxygen gases. Okay. Over here, this lets us know that we need 6 carbon dioxides. And this lets us know that we need 6 waters. Okay. So the way that we figure that out is because anytime that you put, okay, so for instance, if you kept putting money into your bank, put $10, right? Next day you put in $20. How much money should you have? 30, right? What you put in, you should be able to get out, right? Should you be able to get out $30, right? Okay. Now, if you put in $10 and you put in $10 again, and you got out $5, how much money should you have left? Right? So you should have 15 left. If you don't have 15 left, what do you send to the bank?
Somebody stole my money.
Exactly, somebody stole my money. What you put in, you should be able to get out, right? That's what you're saying here. What I'm putting in, I'm saying, I'm putting in 6 carbons. Oh, that's 6 carbons. So at the end, even if it does react with something, it's changing spots, I should be able to get 6 carbons out because that's what I put in. Okay? So it's just accounting for every element that you're putting into the reaction. It's an accounting. Keep track of it. Okay? You guys with me so far? Okay, so I have a lab plan for you guys, but I think what we're going to do, because the lab won't take you that long. It's a kind of fun lab. We may do the lab tomorrow. You guys mind if we stick on this a little bit? And what I'm going to do is put you guys in groups of like 3. Second, I think groups of 3 kind of work. I'm going to give you a whole bunch of these, right? And then I want you guys to work on it. And then what we do is have you guys in that group of 3. You guys come up with
We have homework on this?
We'll have it. You don't have homework on it. Okay, so, because this is one of the most important things about chemistry. If you cannot balance a chemical equation, you're going to be right? So we want to make sure you guys are. Okay, so let me give you guys a couple of reactions. I'll write them over here, and so it'll show up on all of the boards, except for some reason the CD does not work. And I'm not going to tell you which one I'm going to teach. So I'll let you guys pick your groups of 3. Now, what I also recommend, I strongly believe in, the blind should not be leading the blind. If you don't know and anybody in your group don't know, you should probably look in another group, right? Because it does no good if everybody in their group don't have a group, right? So split up. I know you guys like each other, so here's an opportunity to make me friends. There'll be some that-
I know how to get it to the point where I want to, and I don't know what that was like, I think I understand.
Oh, we can touch.
And I'm so embarrassed.
And then also start.
No, it's like.
I think she asked for it like that. That's what we're talking about. And I said, and I had to stop because I was like, literally, I was like,
And then we messed up a lot, like, so dude, like, she was like, keeping it like.
when it happened.
I like to win.
I like one of these. What's better?
Oh, no.
They work there? Work there. Well, I have work friends.
Wait, where do you work?
Big five years.
It always comes there too.
Oh,
Because
oh.
it's months.
Oh.
So that's what I'm checking.
Like write it down again and check.
Well, he's just gonna give us one.
Oh, yeah, yeah. Yeah.
Okay.
That's what he had
One guy she left right now.
Wait, so it's okay, you're just telling me.
Yeah.
Yeah, they go through the
I know
I apologize.
Hey.
What did you do? Yeah,
We're
I
not
like there is one for the H2O, for the H2. Because it's a four. Because if you put it right here, it's four.
And then when I read,
Okay, so.
You have to do that one here, so that's gonna make that a four.
How do you even add it right there? Because it's together.
I didn't see. I'll do the writing room.
That's what I said.
So I think he knows that we're kind of.
Yeah.
yeah.
Well, it's because like in every so if you look at one teacher and then you go doing the same thing that that one teacher taught you, you're like not doing that.
I don't know, it's a big school. Limo's a big school, huh? Condensation.
Oh, yeah.
You do? Oh, shit, that's okay.
We graduated before.
Uh-uh.
Oh, then never mind.
Oh,
Oh, those free.
I think we're like Kelly and then our other cousin just graduated. Found of it. I know she wanted to know.
Oh, yeah. Donovan is there.
Yeah. She didn't have anything else to go.
They would get They went to Stratford.
Oh.
Are we doing all of them?
We're doing all of them.
Oh,
And then
the one of the.
there are roughly 8 groups. out of what's something.
Wait, please, please.
No, you probably haven't seen me around.
But I feel like when I went there. Is that soccer?
Right.
I did.
But some papers like.
And you're our class, right?
All of them. You're doing all of them. And then I pick one for you guys to do on the floor.
Gabby's L'Oreal.
And then
This is that's my boyfriend's cousin. Yeah. Wait. Kelly? Yeah, but Julian's L'Oreal. He's from here.
Yeah, I have.
yeah, that's yeah.
She's like.
Okay, so we have eight.
I know, I'm like, oh.
So, 2, 2, and then 2, 1.
Yeah.
On the reactants that we have 2 hydrogen, 2 oxygen.
No, yeah, I meant to.
Oh.
So the whole
And then
is
it's
balance
that
out with the oxygen.
manganese. Manganese. No, manganese. Is it MN? Yeah, MN. 25.
Oh, it is manganese. Manganese.
Or you can make it manganese. You put 2, this will make hydrogen 4.
Oh,
And then 2 times 2. That's like
oh yeah, magnesium is MG. Yeah.
I put 2 on each side.
Yeah.
Like,
I remember I did all.
4. And then
I did, I printed it was tiny one. Little, and then I was sitting.
I remember
Like, I think
in front of the easy way.
I really thought at the end of the day, when I was studying, I remember everything.
same.
I don't even want
We didn't have to memorize these songs.
No. You got it inside of this. Metal, 2. 1 times 2, right?
Yeah.
That's right here.
Yeah.
Oh, it's already
No.
2. So we have to put a number in front of it. Oh, at all? Oh, okay. Oh, okay. Let me
on both sides.
on both sides. We'll make hydrogen 4.
I don't know why when it reads this, but
It'll be
I thought it
2.
was all
2.
Yeah, it's such a-
This will be 2 times 1.
or when it reads the smart point.
Yes, it's been
And then
saying
it's all
so.
rebalanced.
Oh, yeah.
She does.
I forgot that the time you have to add.
I told her, I was like, just get out. I was like, girl, I need to go. I was like, oh, I
Did
need
it taste
to.
good?
No.
No. Yeah.
So I was like, why do you speak?
Oh, I'll let you try and move it, and if you can leave, I'll just ask you.
Okay.
So,
Put on the one, right?
This
Goes
song-
NA.
No, and A's together.
If it's capitalized, it's all good.
No, SL is sulfur unoxidized.
Oh, we didn't have one.
Yeah.
Oh, yeah, we did have one.
But they're like a
The one with the parentheses, number 2, example number 2. We had
I still think it's a.
You still don't get it?
It's the parentheses.
Okay.
So we just like.
Distributed, yeah, it's distributed, so 3 times 4 is what? 12, so that means I have 12 oxygens in that parenthesis, right? And then 3 times,
Multiplying it.
what does that
You're
equal,
right.
right?
Oh, okay, so it's just like.
Yeah, it
so
makes,
Just the inside.
exactly.
Oh, okay, okay, yeah.
But 4 is 12, right?
Yeah.
Yeah.
So look, so you can have to, yeah, because like example number 2, you had to multiply. 4 times 4 on the outside was 8, and then plus the 4 was.
Because I was 3 times. So I have 7. Oh, you're gonna add it. Oh, like.
Yeah, 4 times 3 is.
Wait, so for oxygen, it's what?
Plus 4.
On what side?
Oh, this is where we have to type this, so we 12. and plus 4. phosphate. And I look back to example.
It is phosphorus. Oh, phosphorus. What's phosphorus?
So you're left finger over right.
I think I have like 20 different handwritings. That's bad, huh?
Wait, what is phosphate?
Am I saying a word?
What's the word?
For us, what's that?
Phosphate. You guys are probably repeating for
What's an F?
Okay.
No, that's the word.
France.
I don't know how to explain that one. That's what I'm talking about. I don't know how to explain it.
Well, that's right.
Even if it's iron,
There's gotta be a little bit. That's real
I don't feel like I'm
Might
that
be-
good.
Oh, do you remember when we had a?
We're 16, right?
We had to make our names.
All right, so we got everything. Yeah,
Isn't it PH?
So balance the.
Oh, it's 16.
I'm not balance the. Write down how much you have inside.
Wait, where is that?
Get that part?
I'm not crazy.
Yeah, so do that.
Oh, yeah.
Yeah, it is.
But did you read something about it?
No, I haven't.
And then when we ask
Or is
this,
it-
this one up there, plus 4 phosphorus. Nothing. Option 4.
Yeah.
Option 4. Of phosphorus.
He's phosphorus, yeah. No. What's phosphate? Phosphorus? Yeah. Because it's when you combine it, it becomes phosphate. Yeah.
There's no right or reason. It's just.
I'm the only one that is.
Yeah. I'm just saying. If it's one of these here, one of these over here, compounds, those stuff like that. So I always sort of. For instance, yeah, sodium, right? Sodium is- I'm sorry. Phosphorus is one time. Manganese. That one, all on one side, on both sides too, right?
Yes. No, wait. Yeah, no.
The last one. I was thinking that was-
Plus 4, yeah. 16. Period. In high school.
It's gonna be this whole chunk right here, right? We wanna go all, because no, we're not gonna plus sign. Yeah, 4 times 2, and then the rest of 2 on my end. For the
And then
oxygen. So we have to add one.
I mean sulfur. Sulfur is 1, it's 3 1. Yeah. But I would have yes. Wait, what? Yeah, 8.
Well, another.
I was 16. On the right.
Hey, now the next part.
So this is the
Oxygen for the time support. I'm February 20. Right? Right.
phosphorus. So should we work on this side? Wait, it's 1 and 1. Yeah, there.
Right?
Here.
I would change our searching So then we're working on balancing it out. Unbalanced. So you put a 2 in front of him.
I put a 3. I put a 3 on the NA. Oh. So it brings to
Those two extras. I got it.
Three instead of a two.
One for me. She got it with the three. I got it with the three. So I got oxygen and sulfur to align together.
Okay, we'll just do it. We'll just do
Because it's gonna be 6, 1, okay, for NA, 6.
So I mean, you have to
Because
focus on You can switch it to agree and see how time.
yeah, it's all together. All of it? Yeah. Because it's like this was a 1 and this was another. No, it's all together. You know what I mean? Oh, wait. No, it's all together. Oh, just make sure.
Could I give you the 3?
No, the first one.
So. Yeah.
Oh, yeah.
These are separate too, right?
Oh, shoot, we have to go.
I think we're just doing numbers. Yeah, we have to do it. We have to get to. So make. Whoever the first one back to the reaction. Well, it's not going in order. Two and then just pick whichever one to do. That's what we have to follow. Well, no, like, let's play it out right here and see what we get on the end and then go back, because we always have to balance it out until it's balanced, you know? We're gonna sort of- We're gonna keep it down.
It's like, I thought you actually had it.
One, it's a regular one.
Already, it's like, okay, so then it's two. Yeah, but if you do the two song, we'll play the other side.
So it'll be ended up with 20 oxygen at the end of it.
You know what? We
Everyone's just doing another NH.
Yeah.
2 MN, 2 phosphorus, and then 20 oxygen. So it needs to go on the other side.
So we're gonna put it go back to two. Okay, so we're gonna switch it back to two for the M. No, yeah, we go back to two.
What type of should
That one.
So right now we have
That didn't work.
2 times 1, which is 2. We have 2. And we have 2 P's. We have 2 times 4 is 8 plus 4 is 16.
It'll be.
Oh, I did it. I freaking did it. I put it on there. Yeah. Yeah, I did it. No.
Yeah, you want to shoot for the end.
Oh,
I know what you're talking about, but 4. So we have 4 in it. So do we leave the 3 that we have 4?
oh, yeah, right.
Or you never put the 3?
2 in.
Yeah, I put the 3 too. I put the 3 too.
4.
So if we go so that is 2 and 4. No.
Yeah.
Good. We have 2. Unless I just put it wrong.
Write down.
I'll say that.
Because I should have taken this here.
Because I didn't go
Where'd
that
you
far.
get this? Where'd you?
Yeah, oxygen.
Yeah, it's way in the front, but over this side.
Now let's go back to the other side.
This is
So we have four.
So that would be 12.
We have 4 and we have too much money now. We have 4 and 8.
And then the 12 and
2 people,
which is
we have 16 of
8
oxygen.
and 12, and that's the
2
same thing that
of
over here.
2 of timid.
Okay, but you can see it. Try to read our side. So it's 6, 1.
I want white board.
We should get a little one. No, we should get a little whiteboard. They do have a little. They saw. Dollar General. I'm gonna go one. That's
We can go back to 3.
Don't you get scared when it starts getting big? Like,
No, because of the one.
You're super smart.
Got a 2 in front of it, look, 4.
I'll do that.
Let's try it. Let's try 4.
I think that one was probably the
Give you
hardest.
guys 7 more minutes.
Gosh, I'm spending all my time on number 2.
Get the
You
rest
wanna
out.
go back to number 2? We can erase the whole thing, and go back to number 2. Go try it. We're on 3 now.
Because we need enough time to talk about it, right?
Yeah.
These are shorter. So
Yeah.
let's skip number 2. Let's skip number 2. I'm gonna erase it. So I'm gonna go to a different question. Bring my brain too much. So we're gonna go to number 3 now. And we'll answer. We're gonna go to our question with the number 3. It's 14.
Yeah, I got 6, 14.
Yeah.
Did we not just do that? I just did this one. Yeah, we did.
It's up here.
Yeah. That was weird. We did it.
Wait.
The numbers are the same.
No, it's not. The 8 to the 14, the 8 to the 12, and 4.
Okay, but we were like right. I remember the 1, 2, 3. I don't know where we did it. I don't know where we did it.
Yeah.
Just that the numbers are-
So I have a question for number 3.
Mhm.
And it's still 6, 14.
You would do the parentheses with the 2 and then it's gonna be like cross it out. So it'll be like, oh,
What times 2 makes 6? 3. So we have 3. Right? So we're gonna have 3 in front of this.
why 3?
Because what times 2 makes 6?
What side are you?
But they're
Does that make the oxygen 12, right?
No. Oxygen, yeah, 13, 12 plus the other one on there.
And then I think it's 3.
Or no, maybe I just, because 2.
What did we have?
A 7, yeah, a 7, and then maybe 13 or something.
Why wouldn't you?
Adding a 7.
Let's see, oh, yeah, that's smart. That's why I got it 3. It's 7 plus 12? Because it's 7. Oh, weren't you gonna because we put the 7 in front of the 8, right?
I think you should put 7.
7.
Yeah, we put 7. And she put 7 on the other side.
Is it 14?
And then you add a 7 on the other side of where O2 is.
Oh.
So what'd you get for oxygen?
13 and 14.
Yeah.
Because if you add a 7 for 3, 7
But look at, there's a 12 right here.
It's 13.
No, because we put a 6 in front of the CO.
Awesome.
Okay, okay.
We put the 6.
6.
Don't laugh at me.
See, I got 13. Yeah, I got 13.
Yeah. That's from doing this.
Yeah, then it's
Was it like 12?
7 doesn't change it.
Yes, it does. So, cause
No, I know, but 7 doesn't change it.
yes, it does.
Oh, yeah.
Yeah, 7.
The 7 plus the 12. Would you get it now, 7 plus 12?
Yeah, I have the same.
So it would be
That was
19.
7 plus 13.
No, because 6 times 2 is 12, and then we got 13.
Plus the other one.
Which is the one that we were messing around with, 7. It would be 7 oxygen for the H2O. Yeah, and then we had 12 from the CO2. So it would be 19.
So hungry. Okay. 7.
We're changing it.
No, no, we're not. So we're gonna have to do the bullet when you multiply the equations. That's true. So should we do the bigger number for 3? That or less than 6? Instead of 7, I should be like 3. Oh, we got to oh, no, that's how it was 1 multiplied. That's what I thought. But it's the biggest, huh? I thought it's what multiplies the number 6. That's what I thought. That's why I thought. Yeah, that's what I thought.
I'm all like.
Right? Because it would technically be 6 times 2.
Yeah, I tried. Come on, guys.
Yeah? You want to change the 3 to a 6?
I mean,
Yeah.
come on, this is
I don't think I have to, because it'd be 6 times 1 based on minus there, but it's going to go with that balance. Yeah, that's just 1. But I'm saying that 6 times 2.
Well,
Unless you guys want hydrogen. Oh, let's go hydrogen like 4 hydrogen. No, but it'll be like, so like, so we're starting off right here. We're gonna take off like 7.
what was it?
6.5.
So what's that in the
So
front?
we're switching this to 6.
And then it's saying 9.5 and then multiply by 2, what's that in the front?
Then with that,
That's the number. Yeah,
Because in the other equations, the reactions never stay the same. After we went back to the reaction, 5 and the reaction 2.
I know, so you want to go to the other side.
Yeah, because you start with 9 down.
19.
Over here.
Yeah, and then to take off the yeah.
So
It's gonna be the same.
all the numbers are to go from that to the back.
It's just not done, right?
Okay. You guys ready?
Yeah.
Yeah, no, yeah. What's that?
I know, watching you.
Okay, so go ahead and volunteer for number 1. Okay, so they're first one. Go ahead, you guys. And you gotta give instruction. You can't get up there and mumble.
Can we bring up our notebook?
You can bring up your notebook.
I could bring yours though.
You don't need it, but
I don't even know.
okay, we'll erase it again.
Okay, do I have a volunteer for number 2? Yes, sir. Okay. You guys want to do number 3?
Yeah, what's the number 3?
This is number 3.
What did number 4?
This is number 4.
We'll do number 4.
Number 4.
Look at number 7. I'm like looking at it.
Okay, so it would be 1C, right?
Okay, let's do number 7 then. Let's switch off for 7. I don't know, we just look at it. Turn it around.
Yeah.
You turn it around.
48. And then the other side is what's saying.
Okay.
3 oxygen
So we have magnesium.
and
We
2
have hydrogen.
right?
Was that, should you guys do 7? Yes.
So that's 2. 12, and then so that's 13. Plus sign.
Yeah. This is 1 and then 3, right? 1 and 2. So it's 1, 1, 1, 1, 1, 2, 2, right? Or am I-
Hold on. Oh, wait.
Yeah. Yeah. 2 on this side and 4 on top. Yeah. Yeah, 1, 1, 1. So.
Tell me that you're 4.
Yeah.
So when I have 2, just do that one.
No, that doesn't.
When I have 2, times 2. Two.
Okay, that's all.
So hydrogen will be 2 times 2. Magnesium, we can keep
Yeah.
keep it 1, right? Oh no.
Everything else is the same.
Well, okay, so what?
Okay.
So what can you make?
And then go back to this side.
It's on the website.
7.
And then add 2 on this side, right?
So then that means 2. This.
Yeah, just 2 on hydrogen, on both the hydrogen, right?
So then like carbon oxygen.
But then it'll be 2 times 1.
Which is this number.
You like go back to it.
No, because the chlorine, the chloride or whatever happened.
Yeah. 6.
I don't know.
Oh, yeah, right. So wait, so what?
Yeah, but then it's still unbalanced.
Oh,
So I'll add 2 on this
What
side.
can I, what can I multiply?
It would be 3, right?
Next to the, next to the hydrogen 2. Yeah, 2 on hydrogen on the side. Oh, I put it on the opposite side, that's why. I put it on the other side, I put it on the product side.
Yeah, that's where I was thinking.
She put it on the reactor, I put it on the product. Yeah, I was like, what? I was like, what's going on?
We gotta work on that part.
I think it is, I'm pretty sure, yeah. Because it makes sense. Because it would be 2. It's really 1, 1 and it's even already, 2 and 2.
So.
It makes 1, 1, it's like 1, 2. Yeah, but that makes so much sense.
Yeah.
I was trying to
Doing it on the
I was
opposite side.
I was doing it on the product side instead of doing it on the reactor side. You did it on the reactor side. I was like, no, it makes it 4. How does it make it? When you're asking how to
Oh,
do
wait,
it.
wait.
So I added it on this side. and then it was 4. Okay, that makes so much sense. That was really good. That's true. That's true. But we balanced it out.
Yeah.
That one was good. I was just trying to figure out how the hell. I was like, it's 4.
Yeah.
It's 4.
So then which one? What?
Oh, there's two right there. I'll go back up there. You and I had 30 hours. 30 hours. The actual day off.
Okay, yeah.
We're still in 30 hours. Whatever.
You guys, everybody, did you guys explain it?
No, no one was really listening, so we're like, oh,
That
Just
doesn't mean
standing there.
it. Hey, pay attention to me. You need to get the center of attention. Okay, go ahead and explain it.
do you want just one of us then to go up there?
It's good if the group explains.
Okay, so next.
You get to hear a variety of things.
Okay, so first we added the two and then the thought of H2O.
Okay, everybody agree with that?
Yeah.
Anybody disagree with that? No. Okay, good job. Okay, who's doing number two?
Check this one. She actually got four right. I got it. Check the logistics.
Yeah. Yeah. We're gonna do the four is C.
For what?
So far we have C. O.
Oh, yeah, 19 over 20.
Anytime that you have
Try plus one.
Yeah, we have the little.
Just really see if you need something similar to
If it
that. Two oxygen plus one. Is three. And then
So 19.
hydrogen is so it's one, two, three. I'm trying to change the numbers.
So oxygen is only takes the balance.
Was that your right?
Well,
Says you're off. Because before
But was it
that-
longer as 7 instead of making it 7?
Because you haven't finished, right?
So do I multiply all that by 2?
You have to multiply everything by two.
So once
Yeah, it's gonna
I
change the whole
multiply by 2,
equation, but we
even
can
out?
just change it.
Yeah, so that means everything has to be multiplied by two. That's how you get rid of it.
That's why. What number does it have originally?
It was 19.
No.
Oh, for H2O?
So they raised the number. It was 6, right? Or 6 CO2.
Yeah.
Guys ready?
Okay, guys, this is how we solve problem number 2. Ivan's gonna explain.
Rick got filled out, started by. Yeah, that's still on that side. On our side.
You guys agree with it? Yeah? You guys understand it?
Honestly, I think that like capital letters when it's both individual ones, they're not gonna have to do letter like that's.
That's right, that's what it is. So I'm glad you brought that up. So that brings up two things. Is there something that you wanted to ask? You asked me first. Okay, so when we talk about symbols, and this is really, really important. This is one of my major pet peeves. I get so mad when people do this, right? So you want to take note of this, right? So symbols. Symbols can either be a single letter, it's going to be a single capital letter. So in, right? Or it can be two letters, occasionally three letters, also, right? Now, NO is different than capital N, capital O. You guys do me a favor, put a periodic table. Okay, capital N means nitrogen, capital O means capital N, lowercase o means nobelium, right? It's a different thing, right? And so you want to make sure that you're writing the chemical symbol correctly. Because if you're not, you're going to end up getting the wrong thing. Okay, so that's the first thing, right? So this is one element, right? It's going to be moving as an element, doesn't say no. This is two different elements. It can separate. It doesn't have to stay together. Okay, you guys understand? Okay, so that's what. So what was the other thing? It was about. Okay, so these are compounds, right? We already agreed to that. Now, this compound is that compound. It defines that compound. So you can't change the subscripts. The subscripts are set. So you can't put an extra 3 here or an extra 2 here, right? What you can change when you're balancing the chemical equation is the coefficient. So normally what we would do is, like, once you guys get to that point, the first thing is we would define what that compound is. So if I gave you a name, you should be able to write out what that compound is. You guys can't do that. We're still at the very beginning. Right now, we're just working on balancing a chemical equation where we've already given you the reactants and we've already given you the products. And so the thing is that you're going to change it here is just the coefficient. Again, the number that's in front of here is called the coefficient. Okay. So how are you guys doing?
A lot
Good?
better.
A lot better now, so a little bit clearer? Okay. Okay, good. Okay, so you guys are doing number 3. You guys ready? No? You guys want some help? Okay, so how about I help you guys with number 3 to kind of keep things moving? And I think we're gonna have to pick this up because we're close to time, right? We're at it here at 12:05. So. Now, is this helpful? Is this process of you guys getting together in groups and working in groups helpful?
Yeah.
You know, this is called community learning, right? Each one teach one, right? So you guys are kind of helping each other through the process, and things that you picked up, you're helping each other through. This is the best way to get through programs, right? So most of you guys are going to university programs, you guys are going to take the same classes, you guys should be talking to each other after you finish this class, say, "Bro, what class are you taking next time?" Right? So you guys end up in the same class. That way you get used to getting groups established. It's the best way of learning. That's the difference in a lot of cases between an A and a C, right? Is by getting together and working in those groups, when you fill in those gaps. Okay, so you guys are the hard part. Let's get started.
I'm like, I want to finish that.
Can I get this, extra one?
I mean, I should go. Let's just show.
I took it maybe to the first day online. It was too much. I was like, we had to buy the lab and all of that. I had to get out of here. It was just weird. So I was like, I don't know, working. And then I took the last semester, and I was very low. I was like at 67.
Yeah, are you working now?
You didn't know to look for. I look like we're so
This was
teaching.
the last thing I learned though.
Oh, really?
Yeah, so that's when working on everything that's. Because I didn't really pick this up.
What? No, he's not doing it.
Okay, so I got 265.
He wasn't doing it. He was in fireball. For what? We thought he was the only class he had was fireball. All the way over there? Oh, it's because. It is, but it's in fireball. Have you registered? For all of them? You could do it. I don't know what it is. We wanted to get. Yeah.
No, they're one unit, one thing that comes together.
So if that. Like there's.
What time is it? 2?
No, how's that? Okay, yeah.
Oh, I did one. Oh, some parts. Oh.
So once I did this,
I thought it was, as soon as you decide you put a number, you put 3 in both, that's 1, so 3. Because you're 1, so 3, you add whatever you add.
Four, right?
Yeah.
Just that, oh, 2. Yeah. Oh.
I'm not even paying attention.
So, that's another thing, I always do that, I have to catch myself.
Still on balance. It would be 3.
yeah, last time I saw it, like,
Yeah, it's kind of, I was like. I read one. Every year. No, every year. So I need to see. I was one. I can't pop up. Actually, you live here.
I don't know. Okay, so you can add a 3 to the side, which would be 6. Plus the 1, which is 7.
Okay.
So, we're doing.
7, and then you don't have to add anything to 5, and then plus the 1, 6. And then just add a 1 to C.
There's somebody teaching.
And it's 2.
I know.
So it's 2, it's balanced now.
Yeah.
It's 2, 6, 7.
Always check.
I think.
I was overthinking.
I was like, wait, I don't know. I was like, I was three. So I'm just like, okay, I think I got that right. That one's good, I think. So whoever does it fast, oh, 267. I'm just like,
30 minutes.
oh, I'm safe.
Oh, but I went fast.
Yeah,
So
I
I
got
wonder
here
why
like
she went right.
That was a Jeep. I had to stop sign.
No, actually 3 times.
No way.
Yeah.
You got 267?
I didn't see it, but the one where my brother was.
No, like it's another one.
So see.
Yeah, it's like the angled one, and then you guys like.
And there's yours one this way.
I didn't see it.
So I kept like.
And then 2 times 19 half. So, you got it.
Yeah, they were going to make their.
So,
So they should go into.
I don't understand. I don't want the best. It gives me hard.
I got it.
Yeah.
Let me see.
So 6, 12, 6, and
I'm all looking at 5 like this girl.
2 times 6.
Oh, well, you both. And then I remember to like. And then.
we're on the right track.
How the city is.
Is that 7 H2?
It's plus or
Okay. So you guys want to explain?
Yeah. Because then we add the C that's on this side.
Why don't we-
No?
Yeah, you guys can start. You guys can start.
It'll be 2 times
Okay.
2 is 4.
And then I was 1.
Well, we working very hard.
Hey guys, you put number 3. Everybody got number 3? Excuse me?
I'm sorry,
Number 3?
sorry.
The 2 in front of this one, you can see it.
Just start off where you got it from here. Start off here. You don't have to get too far ahead. Start off here. Yes, you started off with how many carbons? Okay. So then you guys did, but 6 there, right? Okay, so that gave you 6.
Hydrogen 7 on there. So it's plus. Doesn't reach us. So oxygen plus there.
Okay, so we know that we have 19 oxygens, right? So, and this is O2. So that means that what can I get to give me 19? What can I multiply this by to give me 19, right? So we're multiplying by 2, so obviously I'm going to use 19 halves. Now, if this was a 3, I could use 19 thirds, right? And I will show you an example of that. That's very probably tomorrow. Okay, so 19 halves, and then that would cancel that out. So then, in order to get all of this, right, so that I don't have a half of a molecule, right, I have to multiply everything by 2. I multiply the whole equation by 2, right? And that's exactly what they did. Multiplied everything by 2. 2 times 1, so then that gives me 2 of C6 H14. 19 halves times 2, well, that's 19 oxygens, right? Then 2 times 6, that's 12 carbon dioxide. 2 times 7, That gives me 14 moles. Okay. Now, these are the tricky ones, right? These are the ones that are a little more complicated because you guys have to remember to multiply them by. There's other ways that you can go about doing it. And a lot of that is trial and error. Okay. Questions? Concerns? Yes. It doesn't necessarily cancel out, but it lets it access it. That's how we got the 19. Yeah, this has to stay because you can't change the compound. Okay, so this is the thing that I want you guys to understand. You've got to put it in your head, right? And a lot of you guys have talked to me about it in different ways. So for instance, this here is one compound, right? You can't change that compound. In a chemical reaction, it changes over here, but here it has to be that compound, right? So you can only change the coefficients, meaning that you can only change the numbers that are in front of it. You can't change this compound. So you can't just magically put a 2 in front of this, right? You can't just magically put a 2 on the outside of this, right? You can only put a coefficient in front of it. And so what you're doing to the manganese, you're also doing to this. This is called sulfate. This whole little thing together, it's called sulfate. This thing is called manganese 3 sulfate. You guys don't need to know that yet. We'll get you there, right? But what I'm doing to this, I have to do to this as well too, right? So if I put a 3 in front of here, I'm doing it for both of these. You guys understand?
Yes, sir.
Okay. So, but that's the thing that you want to remember because you guys want to do that thing. You want to change it. Like you were just talking to me about here, this O2, right? It has to stay O2. It can't change because that represents oxygen. It's always going to be oxygen, right? Yes, you guys got that? Okay, so it is 11:58. What I'd like you guys to do, those who didn't give their presentations, you don't worry about it this tomorrow, right? First thing that we'll do tomorrow is do this. So be ready, right? And start the homework. I've actually added some more balancing chemical equations to your homeworks. What was that? Balancing chemical equations. Yes. I've added it to your homework, so that'll give you guys some more practices. Start your homeworks. We've gone over some of the stuff. Tomorrow we'll finish the rest of the stuff, and I will get you the lab. You'll notice that my schedule, I have a plan. I always have a plan, but sometimes, particularly in the beginning, because you guys are rusty, you know, some of you guys claim you have chemistry, right? Some of you guys, you know, your math, fractions, and stuff. So we're still a little rusty. We're kind of fresh off the top. So in the beginning, we may need to go a little bit slower to kind of get you guys caught up. And then once we get you guys caught up, we're going to speed up, right? Okay? Okay.
I don't know. Fast pass. You can send that.
I give you guys some practice. Okay. Okay, any other questions? Okay, wait. Before you guys have a minute. Give me my minute. Okay, make sure you guys close up this, put boxes away. That's one thing. The other thing is your groups have been assigned except for those people who are not enrolled in the class.